Pozzuoli didn't just shake, it cracked open. In the early hours, the city was still half asleep when the first calls came in. Then more, and more. Within just 12 minutes, emergency lines were flooded with 847 reports, all describing the same terrifying scene. Steam bursting through the ground, streets splitting without warning, garages and basements filling with thick sulfuric vapor that seemed to come from nowhere. Residents stepped outside expecting a minor tremor aftermath. Instead, they found the earth itself changing shape beneath their feet, asphalt bending, sidewalks lifting, thin fractures spreading like veins across entire blocks. And from those cracks, heat unnatural rising fast. This wasn't behaving like a normal earthquake. There was no single shock, no clear endpoint, just a growing sense that something deeper was pushing upward, something alive beneath the surface. What made it worse was the pattern. These cracks weren't random. They were forming along a line, precise, almost intentional, cutting through the city in a direction scientists had warned about but never expected to actually see unfold. Because if that line was real, it meant something impossible might already be happening underground. And if this is only the beginning, the real question is, what exactly is rising beneath Pozzuoli right now? Stay informed as this situation develops. Subscribe now for real-time updates, in-depth analysis, and critical insights you won't find anywhere else. This is not just a local event. It could impact millions. Don't miss what happens next. At first glance, the damage didn't look catastrophic. There were no collapsed skyscrapers, no massive craters swallowing entire neighborhoods. But that's exactly what made it more unsettling. Because what was happening in Pozzuoli didn't follow any familiar pattern. Cracks began appearing everywhere across narrow streets, inside residential garages, even deep in underground storage rooms. Some were thin, barely noticeable at first. Others widened within hours, releasing steady streams of hot vapor that carried a sharp, suffocating sulfur smell. People started reporting the same detail again and again. The ground felt warm, not in isolated spots, but across entire sections of the city. It wasn't just surface heat from the sun. This was something rising from below, consistent spreading and impossible to ignore. Even more disturbing was how silent it all felt. There were no continuous tremors shaking the ground, no loud explosions. Just a slow, creeping transformation, the kind that doesn't trigger panic immediately, but builds tension with every passing minute. Experts quickly realized this wasn't a typical seismic event. The distribution of fractures, the release of gas, and the thermal anomalies all pointed to a deeper process, one that wasn't releasing energy outward, but redistributing it beneath the surface. Something was shifting underground, and whatever it wasn't stopping. What scientists uncovered next changed everything. As data from ground sensors, satellite imaging, and thermal mapping began to align, a pattern emerged, one too precise to ignore. The fractures cutting through Pozzuoli were not random surface breaks. They were tracing something much larger, something deep beneath the city. A continuous fissure, stretching nearly 8 kilometers into the earth. This underground rupture wasn't just a crack, it was a pathway. And it was heading in a direction that immediately alarmed geologists across Europe, straight toward Mount Vesuvius. For decades, Campi Flegrei and Vesuvius had been studied as separate volcanic systems, independent, unrelated in terms of direct magma transfer. That assumption formed the foundation of risk models, evacuation plans, and scientific understanding. But now that foundation was collapsing, because the data suggested something unprecedented, a physical connection forming between the two systems, a deep geological corridor that could allow pressure, heat, and even magma to move between them. In simple terms, two volcanoes that were never supposed to interact might now be linked. The implications were immediate and terrifying. If pressure builds in one system, it could now influence the other. If one destabilizes, it may trigger a response in both. This wasn't just an increase in activity. It was a complete shift in how the entire region behaves beneath the surface. And the most unsettling part, this connection didn't take centuries to form. It appeared in a matter of days. Then came the data, and it told a far more disturbing story than anyone expected. A research team analyzing the seismic signals used advanced artificial intelligence to reprocess the initial earthquake readings. What looked like a single moderate tremor quickly unraveled into something much larger. Hidden beneath the surface signal was a dense cluster of activity, tens of thousands of microtremors that standard instruments had completely missed. These weren't random vibrations. They formed a pattern, tight, continuous, and concentrated along the same deep line where the fissure had been detected. Instead of energy dispersing outward, it was being funneled through a confined underground corridor, as if the Earth itself was being pulled apart from within. This changed the interpretation entirely. Rather than a simple seismic release, scientists were now looking at a structural failure. The caldera wasn't just shaking, it was deforming. Internal pressure was forcing its way through pre-existing weaknesses, reactivating ancient fault lines that had remained dormant for centuries. The implications were severe. When a volcanic system begins to fracture internally, it signals a loss of stability. The natural seal that contains heat and pressure starts to break. Once that seal is compromised, pathways open, allowing magma gas and thermal energy to migrate unpredictably. And that's exactly what the data suggested was happening. The ground above Pozzuoli wasn't just reacting to a past event. It was responding to something ongoing, something still building, still moving, and far from reaching its peak. As monitoring systems intensified across the region, the next wave of evidence didn't come from seismic data, but from heat and gas. Sensors placed along the newly formed fissure began recording a rapid and consistent rise in ground temperature. Within a short period, readings showed an increase of more than 12 degrees Celsius in multiple locations. This wasn't a localized spike. It was spreading following the same underground path traced by the fracture. At the same time, gas emissions surged. Fumaroles that had been quiet for decades suddenly reactivated, releasing thick columns of vapor into the air. Chemical analysis revealed a sharp increase in sulfur compounds, particularly sulfur dioxide and hydrogen sulfide, both strong indicators of deep magmatic activity. But the most critical detail wasn't just the presence of these gases, it was their origin. The composition suggested that the material was rising from significantly deeper layers than usual. This wasn't surface-level geothermal activity. It was pressure building far below now, finding a way upward through newly opened channels. In parallel, satellite thermal imaging confirmed a growing heat signature stretching between Campi Flegrei and the direction of Vesuvius. The underground corridor wasn't just forming, it was becoming active. This meant one thing. The fissure was no longer just a structural break. It was functioning as a conduit, a pathway through which heat, gas, and potentially magma could travel, linking two volatile systems in real time. And once that kind of connection stabilizes, it becomes extremely difficult to predict or control what happens next. Then something shifted beneath Mount Vesuvius. For decades, the volcano had remained relatively quiet. Its last major eruption dated back to 1944, and since then, activity had been limited to minor surface-level signals, nothing indicating deep internal movement. It was considered dangerous, but stable. That assumption didn't hold. Within less than 2 days after the fissure formed beneath Pozzuoli, seismic stations around Vesuvius began detecting a different kind of activity. Not shallow tremors caused by surface stress, but deep, low-frequency vibrations originating from within the magma chamber itself. This was a critical distinction. Deep tremors suggest movement below the surface, pressure shifting, magma adjusting, or pathways opening where none existed before. And what made this alarming wasn't just the activity itself, but its timing. It happened immediately after the underground corridor between Campi Flegrei and Vesuvius was identified. For the first time in modern monitoring history, scientists began to consider a direct interaction between the two systems, not theoretical but real-time. Data streams showed subtle synchronization. Changes in pressure beneath Campi Flegrei appeared to correspond with fluctuations under Vesuvius. It was no longer coincidence, it was coupling. Two volcanic systems, once treated as independent, were now behaving as parts of a single dynamic structure. Energy was no longer contained within isolated reservoirs. It was being transferred, redistributed, amplified. And that changes the risk entirely. Because when one system destabilizes, the other may not just respond, it may react. What began as a localized anomaly was now evolving into a regional threat. With evidence mounting that Campi Flegrei and Vesuvius were no longer acting independently, scientists started modeling worst-case scenarios. The results pointed toward a possibility that had long been dismissed as unlikely, a cascading volcanic event, a domino effect. In this scenario, pressure doesn't simply build and release in one location, it transfers. If one system reaches a critical threshold and erupts, it could send shockwaves, both mechanical and thermal, through the newly formed underground corridor. That energy could destabilize the second system almost instantly. 2 eruptions, not sequential over years, but potentially within hours or even minutes. And it doesn't necessarily stop there. The Mediterranean region hosts multiple active and semi-active volcanic systems, many of which are believed to share deep magmatic roots. Etna in Sicily, Stromboli further south, even Santorini across the sea. If pressure redistribution spreads through interconnected pathways, it could trigger a broader chain reaction. This is where uncertainty becomes dangerous. Because current models are based on isolated systems, they were never designed to predict synchronized volcanic behavior across multiple sites. The variables multiply, the margins for error shrink, and the scale escalates rapidly. An event like this wouldn't be classified as a single eruption. It would be a regional destabilization affecting not just one city or one country, but an entire basin. What scientists are now facing isn't just increased activity, it's a system that may be starting to behave as one. For the people living in and around Pozzuoli, this isn't theory, it's daily reality. More than 3.5 million residents now sit within a zone that has fundamentally changed in a matter of days. What was once considered a high-risk area is now something else entirely, a live system with shifting boundaries and unpredictable behavior. The challenge isn't just the threat itself, it's the scale. Emergency plans were built around a single source event. One volcano, one evacuation flow, one direction of escape, but the landscape has changed. With Campi Flegrei and Vesuvius now potentially linked, those assumptions no longer hold. Routes that once led away from danger may now lead directly into it. Major highways connecting Naples to surrounding regions could become immediate choke points. In a rapid evacuation scenario, traffic models show gridlock forming within hours. Communication networks already strained under normal conditions may fail under the pressure of millions trying to coordinate their escape at the same time. Hospitals and emergency services face an even harsher reality. They are not designed to handle simultaneous mass casualties across multiple zones. Resources would be stretched thin within minutes. Response times would collapse. Critical decisions would have to be made under extreme uncertainty. And all of this unfolds while the ground continues to shift beneath their feet. For millions of people, the risk is no longer abstract, it's immediate. What is happening beneath Pozzuoli is no longer just a geological event, it's a turning point. For decades, scientists studied Campi Flegrei and Vesuvius as separate threats, each dangerous in its own way, but ultimately manageable within known risk models. That framework no longer applies. The events unfolding since March have forced a complete rethinking of how volcanic systems in this region behave. Because this may not be an isolated incident. The connection forming underground suggests something far larger, a reactivation of deep magmatic networks that have been dormant for thousands of years. If that's true, then what we are witnessing now could be the first visible sign of a much broader shift beneath the Mediterranean. A first domino. And once that domino falls, predicting what comes next becomes exponentially more difficult. The scale of potential impact extends beyond one city, beyond one country. It reaches into climate infrastructure and human stability across an entire region. The signals are still evolving, the data is still incomplete, but one thing is becoming increasingly clear. This process is not slowing down. So the question is no longer whether something will happen. It's how far it will go and whether anyone is truly prepared for what comes next. Stay updated with the latest critical developments as this situation continues to unfold. Subscribe to the channel for real-time insights, deep analysis, and breaking news you won't find anywhere else. Don't miss the next update. Your awareness could make all the difference.